The Industrial Revolution 4.0, also known as the Fourth Industrial Revolution, marks a transformative phase in human history where digital, physical, and biological systems converge. Unlike earlier industrial revolutions that focused on mechanization, electricity, or automation, Industry 4.0 is driven by smart technologies such as artificial intelligence, AI, Internet of Things, IoT, big data, robotics, and cyberphysical systems. It enables intelligent decision-making, real-time data exchange, and highly efficient production processes, reshaping industries, economies, and societies worldwide. Industrial Revolution evolution. The evolution of industrial revolutions reflects humanity's continuous quest for productivity and efficiency. First Industrial Revolution, Industry 1.0. First Industrial Revolution, Industry 1.0, began in the late 18th century, around 1760, in Britain. Introduced mechanization using steam power and water wheels. Shifted production from handcrafted goods to machine-based manufacturing. Textile industry became the first major beneficiary with inventions like spinning jenny and power loom. Led to the rise of factories, replacing cottage industries. Triggered rapid urbanization as people moved from villages to industrial towns. Laid the foundation for capitalist industrial economy. Second Industrial Revolution, Industry 2.0. Second Industrial Revolution, Industry 2.0, emerged in the late 19th and early 20th centuries. Marked by the use of electricity as the primary power source. Enabled mass production through assembly line systems. Introduction of steel production, chemical industries, and petroleum refining. Development of railways, telegraphs, and telephones improved connectivity. Standardization of products increased efficiency and reduced costs. Strengthened the rise of large corporations and global trade. Third Industrial Revolution, Industry 3.0. Third Industrial Revolution, Industry 3.0, began in the mid-20th century, particularly after the 1950s. Characterized by electronics, computers, and information technology. Introduction of programmable logic controllers, PLCs, enabled automated production. Use of robots and computer-aided manufacturing in industries. Shift from mechanical and electrical systems to digital automation. Enhanced precision, speed, and consistency in production processes. Marked the beginning of the digital economy and information age. Fourth Industrial Revolution, Industry 4.0. Fourth Industrial Revolution, Industry 4.0, gained momentum in the early 21st century. Integrates digital, physical, and biological systems. Driven by technologies such as artificial intelligence, Internet of Things, big data, robotics, and cloud computing. Enables smart factories with real-time data exchange and autonomous decision-making. Focuses on mass customization rather than uniform mass production. Blurs boundaries between human labor and machine intelligence. Creates new economic models while redefining work, governance, and social structures. Industrial Revolution 4.0 features. Industrial Revolution 4.0 is defined by the deep integration of digital technologies with physical production systems, enabling intelligent, autonomous, and interconnected industrial operations. Interconnectivity. Machines, sensors, and systems are connected through the Internet of Things, IoT, enabling seamless communication across the value chain. Cyberphysical systems, CPS. Physical processes are monitored and controlled by digital systems that can analyze data and take corrective action in real time. Artificial intelligence and machine learning. Systems learn from data, predict outcomes, and optimize processes without continuous human intervention. Automation with intelligence. Unlike earlier automation, Industry 4.0 enables self-adjusting and self-optimizing production systems. Real-time data and analytics. Continuous data collection allows instant decision-making, predictive maintenance, and quality control. Decentralized decision-making. Smart machines and systems can make operational decisions independently, reducing delays and errors. Mass customization enables production of customized goods at the cost and speed of mass production. Cloud computing and edge computing provide scalable computing power and storage, supporting flexibility and remote operations. Advanced robotics. Robots perform complex, precise, and adaptive tasks alongside human workers. High system integration. Vertical and horizontal integration connects design, production, supply chain, and customer feedback loops. Industrial Revolution 4.0 impact. Industrial Revolution 4.0 is reshaping economic structures, labor markets, productivity, and governance through intelligent automation and digital integration. The impacts are: accelerates global productivity growth by an estimated 0.8 to 1.4% annually through AI, automation, and data-driven decision-making. Reduces machine downtime by 30 to 50% using predictive maintenance and real-time monitoring systems. Lowers manufacturing and operational costs by 10 to 30% through efficient resource utilization and process optimization. Transforms manufacturing into smart factories with real-time quality control, automation, and mass customization. Improves product quality and precision, reducing defects by up to 50% in advanced manufacturing units. Shortens time to market by 30 to 60% using technologies like 3D printing and digital twins. Reshapes labor markets by displacing routine jobs while creating new roles in AI, data analytics, robotics, and cybersecurity. Leads to a net employment shift, with millions of new technology-driven jobs emerging globally despite automation risks. Government initiatives supporting Industry 4.0 in India. The Government of India has launched multiple policy, institutional, and financial initiatives to promote advanced manufacturing, digital transformation, and emerging technologies. These initiatives aim to strengthen India's readiness for Industrial Revolution 4.0, enhance global competitiveness, and build a future-ready workforce. Indian Semiconductor Mission 2021 aims to develop a robust semiconductor and display manufacturing ecosystem in India, reducing import dependence and supporting electronics, AI, and digital industries. Production-Linked Incentive (PLI) scheme incentivizes domestic manufacturing in sectors like electronics, semiconductors, EVs, and telecom, encouraging technology-driven and large-scale production. Digital India Program 2015 expands digital infrastructure, broadband connectivity, and digital governance, enabling faster adoption of IoT, AI, cloud computing, and smart manufacturing. Skill Development Initiatives PMKVY 4.0 incorporates training in AI, robotics, data analytics, and Industry 4.0 technologies to prepare a future-ready workforce. National Quantum Mission 6,000 Indian rupees crore supports research in quantum computing, communication, and sensing, strengthening technological sovereignty and next-generation innovation capacity. Atal Innovation Mission AIM promotes innovation through Atal Tinkering Labs, incubation centers, and startup support, fostering research and entrepreneurship in emerging technologies. National AI Portal INDIAAI acts as a knowledge hub for artificial intelligence, promoting awareness, research collaboration, and policy innovation. Samarthodayog Bharat 4.0 focuses on awareness, training, and pilot projects to facilitate adoption of smart manufacturing, especially among MSMEs. Make in India 2.0 encourages advanced and technology-intensive manufacturing to position India as a global production hub. Startup India Initiative supports deep tech and Industry 4.0 startups through funding, incubation, and regulatory facilitation. Open Network for Digital Commerce ONDC strengthens digital ecosystems, supporting MSMEs and data-driven business models aligned with Industry 4.0. Industrial Revolution 4.0 and MSMEs. MSMEs are central to India's economy, contributing about 31.1% of India's GDP, nearly 35.4% of manufacturing output, and approximately 48.58% of exports, highlighting their critical role in industrial growth and global supply chains. The MSME sector comprises over 7.47 crore enterprises and employs about 32.82 crore people, making it the second largest employer in India after agriculture and a major livelihood source. Despite strong digital payment uptake and growing formalization, only a fraction of MSMEs currently adopt advanced Industry 4.0 technologies, indicating a need for deeper technology diffusion and capacity building. Enhanced credit growth, expanded classification thresholds, and targeted equity funding under government programs support MSME digital transformation and expansion, but addressing skill gaps and finance access remains essential for widespread Industry 4.0 adoption. Industrial Revolution 4.0 challenges. Industrial Revolution 4.0 offers transformative opportunities, but its adoption also presents economic, social, technological, and governance challenges that must be addressed to ensure inclusive and sustainable growth. Skill gap and workforce readiness. A significant mismatch exists between current workforce skills and the advanced competencies required in AI, robotics, data analytics, and automation. Job displacement risks. Automation and intelligent machines may replace repetitive and low-skill jobs, raising concerns about unemployment and social inequality. High cost of adoption. Advanced technologies demand substantial initial investment, which is particularly challenging for MSMEs and traditional industries. Digital divide. Unequal access to digital infrastructure across regions and sectors may widen economic and social disparities. Cybersecurity threats. Increased interconnectivity exposes systems to cyber attacks, data breaches, and industrial espionage. Data privacy and governance issues. Large-scale data collection raises concerns regarding data ownership, misuse, and regulatory oversight. Technological dependence. Over-reliance on imported hardware, software, and semiconductors can create strategic vulnerabilities. Way forward. Priorities: large-scale skilling and reskilling in AI, robotics, data analytics, cybersecurity, and advanced manufacturing through industry, academia collaboration. Integrate Industry 4.0 modules into school, ITI, and higher education curricula to build future-ready human capital. Ensure affordable access to advanced technologies for MSMEs through subsidies, shared infrastructure, and technology clusters. Strengthen digital infrastructure including broadband, 5G, cloud facilities, and reliable power supply across regions. Promote indigenous R&D and innovation in semiconductors, AI, quantum technologies, and robotics to reduce import dependence. Encourage startup and innovation ecosystems focused on deep tech and Industry 4.0 solutions. Formulate adaptive regulatory frameworks to address AI ethics, data privacy, accountability, and safety concerns. Support MSME digital transformation through capacity building, awareness programs, and easier credit access. Promote inclusive digital growth to bridge regional, sectoral, and social divides.